Okay, so let's get started. We're going to be taking a look in this training module and understanding our SAI torque reduction system in our Ford Gen 3 control module programming. So this is going to be the way that the torque is primarily controlled within the torque control system. So we know we have our driver demand table. That's where we have our certain pedal input and engine speed. That's going to look up a desired torque that we want to run our engine at. That's going to be the request into the system. Now, we have the mass airflow on a Mustang measuring airflow. We have the spark timing being called out from either the borderline or maximum brake torque table, but ultimately we know what the spark timing is at. And then we also know what the commanded fuel is going to be at. We compare the commanded fueling to stoichiometric or 1.0 lambda. We compare the actual spark timing to maximum brake torque. And we also take a look at the air model. We look at the airflow that's coming into the engine, the air mass coming into the engine. The engine control module then can calculate the engine's torque output. It also uses some frictional loss tables to figure out what the true engine torque is going to be, and it compares that to the driver demand request. Depending if we're overshooting that request or undershooting it, we'll find that the torque control system will make adjustments to get us up to the desired torque that we want to run our engine at. Now, we have two forms of torque control. We have a fast path and a slow path. Fast path is going to be used with things like spark timing, fuel enlinement, and or fuel cut. All three of those will quickly influence the engine's torque output. And the SAI torque reduction system relies on all three of those in order to do that fast path of control. So if we're talking about idle control, we're going to be using our spark timing first to manipulate the engine's torque output to hit a desired torque request. If we're talking about something like traction control, well, we'll probably use spark timing to try to reduce the engine's torque output, but we're likely to go into a fuel cut because that's going to have the greatest torque reduction and the output of our engine. Those are all situations where we use this fast path of control. Now, we also have a slow path of control, and that's not generally part of the SAI torque reduction system. That's going to be our throttle control. So the throttle control is known as the slow path of control, and that's going to be because the throttle takes a certain amount of time to open or close, the airflow takes a certain amount of time to change, and the engine's torque output is going to follow that time limitation. So we generally want to control things in a fast path to get the instantaneous output changed out of our engine, which is why the engine control module programming is almost always going to use this SAI torque reduction system. So it's important we understand how this works. I'm going to go through the tables and how everything interfaces here in this tutorial. Rarely do we have to change things in here, but there's some situations where you may have to go in and edit and change a few things within the programming. For example, if you're coming on and off the throttle and you're noticing maybe it's a little bit jerky coming on and off the throttle, you may need to go in and edit some of the torque ratios in the clips so that it doesn't maybe pull as much spark timing coming on and off the throttle. We have to be careful of what we edit and modify. If we edit and modify the wrong tables in the torque reduction system, it can influence everything within the engine control module and transmission control module if you have a 10R transmission. So we definitely want to be mindful of what we're editing, so we need to understand how this system actually works. Let's jump in here to this tutorial and open up a file so we can take a look at understanding this SAI torque reduction system. So I'm going to go in here to the file and then open, and we're going to move into our desktop, go into our HPT Gen 3 Coyote Course folder. We're going to jump into our sample data logs folder and move into this folder here called TR testing, the torque ratio testing. I was doing a couple minor changes into the base file here. So we started off with the stock settings. I was just changing a few things just so I knew exactly how things worked heading into this tutorial. Some settings and tables that I haven't experimented with in the past tuning Gen 3 and Gen 2 engine control modules for programming. So let's move into our TR stock settings here and take a look at a few things. So we're going to jump into our engine tab, and we're going to go here from general all the way across here under our torque management. And torque management, we're going to focus our attention here under the general tab and specifically under the torque ratio tab right here. So we have a lot of tables. It looks overwhelming. Let's break this down of what this actually means. The system is quite complicated, but we should understand how it works, and we can reference some data logs to see exactly how things are implemented in the torque control system in this fast path of torque control. So first things first, under the torque ratio, we're going to find our torque ratio configuration. We have fuel cut torque ratio and spark only torque ratio. If we open up these two tables here, and let's go ahead and close this real quick, we can take a look at these tables here back to back. What this is saying here, looking at this.
Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here, and you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.